Good day everyone. So welcome to our next video regarding system of linear equations. So I'm Mr. Michael M. Flores, your teacher for today for MS 102 quantitative methods. So in our previous videos, we've discussed already how to solve for linear equation in one variable and how to graph or solve linear equations into variables. So system of linear equations, we have two or more linear equations, and we are looking for their relationship, or if they are coinciding lines, if they are parallel lines, or if they are coincident lines. So this topic is a preparatory for the linear programming. Okay, so what do you mean by system of linear equations? So by definition, a system of linear equations is two or more linear equations with the same variables. So for example, variable x and y. The solution of a system of linear equations is the point of intersection of the lines representing the equations. This can be done algebraically or graphically. The algebraic method may be done by elimination or substitution. So when we say a solution of a system of linear equations, it is the common value for x and y of both equations. So in systems, this is the point of intersection. So there are different methods on how to determine the point of intersection by elimination or substitution, but in our previous video, we can use the graphical method. So after graphing the specific linear equation into variable, we can graph these two or more equations in only one Cartesian plane. Okay? So there are different types of system of linear equations. So when we say a system of linear equation is the common point or ordered pair of any two given linear equations. So, for example, our first equation is represented by a sub 1x plus b sub 1y equals c sub 1. And our second equation, we have a sub 2x plus b sub 2y equals c sub 2, our second equation. So, next, the first type of system of linear equations is the inconsistent system. So, an inconsistency has a solution of empty set, and the graphs consist of two parallel lines. It can be determined using the ratio test. So, when you say inconsistent, there are no point of intersection. So, without solving, without graphing, by merely looking at the constants of our linear equations, we can determine if it is an inconsistent system by using this ratio test. A sub 1 over a sub 2, b sub 1 over b sub 2 is not equal to c sub 1 or c sub 2. So later we'll discuss this with an example. So the second type of system of linear equation is called the dependent system. A dependent solution contains an infinite number of solutions, and the graphs are two coincident lines and can be determined using the ratio test. A sub 1 over a sub 2 equals b sub 1 over b sub 2 equals c sub 1 over c sub 2. So by looking at our ratio test, it shows that all the constants of our linear equations are the same or equal. Then, if we will graph this type of system, we will have coincident lines. Sometimes they call them collinear lines. Okay? So this is the second type. Then the third one, we have the consistent system. So when a consistent system contains only one solution or one exact solution, pair of ordered pairs. And the graphs are two lines which intersect at one point. It can easily determine using the ratio test a sub 1 over a sub 2 is not equal to b sub 1 over b sub 2. So why do we need to have an idea, or why do we need to apply ratio test in determining the types of system? Because in linear programming, the first thing that you have to consider is if the system is consistent or not. If it is not consistent, then there's no reason for you to proceed unless otherwise you are required by your teacher. So in linear programming, we are looking for the exact solution wherein these two lines or graphs intersect. That is why you have to be familiar with the ratio test. So if the constants of A and B are not equal, automatically it is a consistent system having an intersecting lines. Okay? So we'll proceed now with our example. So we have three sets of examples here. Okay, we'll try to solve or determine the type of system of equation using ratio test and plot the graphs. So for example, in number 1, we have 4x plus 2y is equal to 16. This is our equation 1. Then we have 2x plus y is equal to 11. So this is our equation 2. So using the ratio test given, we can now determine a sub 1 is equals to 4, b sub 1 is equals to 2, and c sub 1 is equal to 16. And for our second equation, a sub 2 is equal to 2, b sub 2 is equals to 1, then c sub 1 is equal to 11. So applying the ratio test here, we have a sub 1 over a sub 2, then we have b sub 1 over b sub 2, then we have c sub 1 over c sub 2, then substituting the values, we have 4 over 2, then we have 2 over 1, and we have 16 over 11. Looking at our given ratio, if there are some ratio that can simplify them first. So we have 2 over 1, we have 2 over 1, 16 over 11. So what is the relationship? We have 2 over 1 is equal to, 2 over 1 is not equal to 16 over 11. So with the previous definition or examples of ratio test, we can now conclude that a sub 1 over a sub 2 is equal to b sub 1 over b sub 2 is not equal to c sub 1 over c sub 2. Therefore, it is an inconsistent system. So we can now conclude that these two equations are inconsistent. So what do we mean by inconsistent? When we plot the graphs of this inconsistent system, we will only produce parallel lines. So there is no point of intersection. Okay, proceeding with the instruction, we are asked to plot the graphs. So how can we plot the graphs? So same with our previous lesson, we will determine the set of ordered pairs for both equations. Okay? So continuing, we have 4x plus 2y equals 16. So using the intercept method, let x be equal to 0. We could have 4 times 0 plus 2y is equal to 16. Then we have 2y equals 16. Eliminate 2 by dividing 2 both sides using the division property of equality. Then you will get y is equal to 16 divided by 2 is 8. So our y-intercept is 8. Then our setup point or ordered pair, we have 0 and positive 8. Then for the x-intercept, we have let y be equal to 0. So we have 4x plus 2 times 0, replace y by 0, is equal to 16. Then you will have 4x is equal to 16, dividing both sides by 4. Then cancel, we have x is equals to positive 4. Then our x-intercept is 4. And our ordered pair now would be 4, 0. Okay? Then, same procedure for the second equation, which is 2x plus y equals 11. We have 2x. So for 2x plus y equals 11, let x be equal to 0. So we have 2 times 0 plus y equals 11. Therefore, y is equals to 11. So our ordered pair would be 0, 11. Okay? And then for the next one, we have let y be equal to 0. Solving for the x-intercept, we will now have 2x plus 0 is equals to 11. So 2x is equals to 11. Dividing both sides by 2 to eliminate 2 here. Then we will have x is equals to 11 over 2. Or we can convert this as 5 and 1 half, or simply 5.5. Okay? So our ordered pair now would be 11 over 2 and 0. Okay? So these are the set of points that we have. And since we are tasked to graph, okay, consider all our set of points here. Okay. So we may now construct our Cartesian plane. Okay. So for example, this is our Cartesian plane. Then making some intervals, so we have this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. This is our y-axis. Then for our x-axis, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So make sure you may use the same intervals if you have, based on your graphing paper. Negative 2, negative 3, this is negative 1, negative 4, negative 5, and so on. Okay? So we will plot the points of our first equation, which were 0, 8, and 4, 0. So with our Cartesian plane, so we have 0, 8. So it is located here. So this is 0, positive 8. Okay? And then 4, 0 is located here. So we have x is 4, then y 0, so it is here. So we have, I'll just put the ordered pair here, 4, 0. And then using a ruler, you can now connect these points. Okay, so that's it. Put some arrowheads on its end. Okay, so this is now our first equation, which is 4x plus 2y equals 16. Okay, how about the second equation? So based on our second equation, we have 0, 11 as its point. So if we will plot this, it is here. We have 0, positive 11. Okay. And then we have the second, this is our first order pair. And this is our second order pair. So 11 over 2, that is 5.5. This one. Or 5.5. So it is here. So approximate or estimate, it is here. So it is 11 over 2, 0. And we will now connect this. And we will now connect these points. Okay. Then extend these lines. Okay. So this is now our second equation, which is 2x plus y is equals to 11. Okay. So by looking at our graph or our equations, what kind of lines do we have? Do they intersect at a certain point? No. Therefore, we produced parallel lines. So this is the definition or description of an inconsistent system. So without graphing, without solving for the points this one, only using the ratio test this one, you can determine or predict if the given system this one is an inconsistent system dependent or consistent system. Okay? So unless you are told by your teacher to plot the graph, so you have to proceed with this. But if you are only tasked or asked to determine if the system is an inconsistent, dependent, or consistent, just simply apply the ratio test. Okay? So that's how simple it is. So there are many steps to do, but basically the concept is very simple. Okay, so we'll proceed now with the next example. So for our next example, we have 2x plus y is equal to 6, 4x plus 2y equals 12. So for our second example, we have 2x plus y is equal to 6. And then we have 4x plus 2y is equals to 12. So this is our equation 1, this is our equation 2. Okay, using the ratio test, we can determine a sub 1 is equals to 2, b sub 1 is equals to 1, c sub 1 is equals to 6. Then a sub 2 is equals to 4, b sub 2 is equals to 2, then c sub 2 is equals to 12. Okay, so we have a sub 1 over a sub 2, b sub 1 over b sub 2, c sub 1 over c sub 2. Substitute our value, so we have 2 over 4, 1 half, then we have 6 over 12. Simplify it further, we have 1 half, 1 half, and 1 half. So looking at our ratio or the values, they are all equal. So this is also equal and this one is equal. So using the definition for our ratio test, if all the terms for A, B, and C are equal, then you will have dependent. Therefore, the system is dependent. Or we can say that, or it is a dependent system. So recalling our definition earlier, when we say dependent system, what kind of lines do we have? So going back to our definition, we can conclude that we can have coincident lines. We can produce coincident lines with dependent system. Okay, so we can check this if it is correct by plotting the points. Okay, so using the same procedure with our first example, so for 2x plus y is equal to 6, okay, let x be equal to 0 for y-intercept. So we have 2 times 0 plus y is equal to 6. So y is equal to 6. Therefore, we have 0 and positive 6. And then, let y be equal to 0 to solve for the x-intercept. We have 2x plus 0 is equal to 6. So we have 2x is equal to 6, dividing both sides by 2 to eliminate this, so you will get x is equals to positive 3. Then our ordered pair now would be 3, 0. Okay? So these are the set of points for our first equation. Then for our next equation, okay, you can solve it here. For 4x plus 2y is equals to 12. So let x be equal to 0. Then we have 4 times 0 plus 2y is equals to 12. So we have 2y is equals to 12, dividing both sides by 2. Then y is equal to positive 6. So you will have 0 and positive 6. Okay? Then for y is equal to 0, we have 4x plus 2 times 0 is equals to 12. Then leaving 4x is equals to 12 divided by 4 on both sides. Cancel this, you will get x is equals to positive 3. So our ordered pair now would be 3, 0. Okay? So by merely looking at the set of ordered pairs that we produce from our first equation and also with our second equation, they are just the same. Okay? But again, if we will proceed to its graph, okay, so we can make some graph here. Just be patient in making your Cartesian plane. So this is one of the struggles or challenges for most of my students in junior high school as well as senior high and college students, because it requires patience and dedication to create a good and presentable Cartesian plane. But when you are making this graph, you don't need to create a bigger graph. As always, just consider the given set of points that you have based on your computed points. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. Then also you can use some intervals if you want. 6, 7, 8. Okay, so we can now plot the first point. We have 0, positive 6. We have 0, positive 6. So it is here. 0, positive 6. And we have 3, 0 here. 3, 0. Then we can now connect this set of points using a ruler, or if we have other straight edge material. Okay. So this is now our equation 1, which is 2x plus y is equal to 6. Okay? And then plotting for our second set of points, it is also 0, 6 and 3, 0. They are the same. This one and this one. So it can be conclude that this one, they are the same. 4x plus 2y is equals to 12. So this set of linear equations have coincident lines. So the set of points within this line are both seen with these two linear equations. Okay? So that's how it is, how simple it is. So you need to familiarize yourself with this ratio test. Without solving, just simply looking at the relationship between the constants here, you can determine already right away if the system is dependent, inconsistent, or consistent system. Okay? And if you need to plot, just simply solve for the x and y intercepts, determine the set of points to consider, then graph it using Cartesian plane. Okay? So for our last example, we have number 3. We have 2x plus y is equals to 16. Okay? So maybe you have already an idea what kind of system is our last example. Okay, so for number 3, we have 2x plus y is equal to 16. Then we have x plus 2y is equals to 11. Okay? So we have a sub 1 is equals to 2, b sub 1 is equals to 1, c sub 1 is equal to 16. Then we have a sub 2 is equals to 1, b sub 2 is equals to 2, then c sub 2 is equals to 11. Okay? So we have a sub 1 over a sub 2, b sub 1 over b sub 2, c sub 1 over c sub 2. Substituting our values, we have 2 over 1, we have 1 over 2, we have 16 over 11. Wherein these ratios are not equal. Okay? Okay? So, if we do not have equal ratios, what kind of system it is? Therefore, it is a consistent system. What do you mean by consistent system? If we have consistent system, what kind of lines do we have? So we can produce intersecting lines. So when we say intersecting lines, it has point of intersection. So by definition, okay? So again, how can we determine a given system of linear equations in two variables if they are consistent system? So just look at the ratio. If ever the first two ratios A and B are not equal already, then automatically it is a consistent system. So with this type of linear equations, we need to focus on this because most of the linear programming problems are about consistent system. Okay? So to prove that we have an intersecting lines and a point of intersection, we have to plot these points or plot the graphs. Okay? So same, just be patient on solving or graphing. So for our first equation, 2x plus y is equals to 16. Although we have solved it already in our previous example, let x be equal to 0. So we have 2 times 0 plus y is equals to 16. Then we have y is equal to 16. So our ordered pair would be 0 and positive 16. Okay? So for let y be equal to 0, so we have 2x plus 0 is equal to 16. So we have 2x is equal to 16, dividing both sides by 2. Cancel, cancel. So x would be equal to positive 8. Then you will get 8, 0. So that's how simple it is. Okay? So you now have two set of points for our equation 1. Then for equation 2, so for x plus 2y equals 11, let x be equal to 0. So you have 0 plus 2y is equals to 11. 2y equals 11 over 2. Over 2. Cancel. Y is equals to 11 over 2. Or this is 5.5. We will simplify. Okay? Then let y be equal to 0. So we have x plus 2 times 0 equals 11. So we have x is equals to 11. So we have 11, 0. Okay? So these are the set of points for our two equations. Okay. Then for the graph, you have to create a Cartesian plane here. Since both of the given are positive, so we can create a bigger one here for our graph. Okay, so put some label here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is our x-axis. And for our y-axis, we have this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is our y-axis. So this is negative 1, negative 2, negative 3, negative 4. So when you create your Cartesian plane, make sure you use the same intervals. Okay? And suggestion, or as suggested, the numbers on the y-axis must be on the left side, and below the x-axis are the numbers. Okay? So we can now plot. Oh, we have 0, positive 16. So it's not enough. 12, 13, 14, 15, 16. Oh, it's over here. Sorry. 13, 14, 15, 16. So we extend our Cartesian plane. So we will plot now. We have 0, positive 16. It is here. We have 0, positive 16. Then 8, 0. It is here. So this is 8, 0. Then connecting this set of points. Okay. So we have this. Okay. And then, for our second linear equation, what are the set of points we have? Oh, I forgot. Okay, so we have this 0 and 11 over 2. So 0 and 11 over 2, that is 5.5. 5.5 here, okay? So that is 0 and 11 over 2. And then 11, 0, it is here. 11, 0. So, okay. So it is here, 11, 0. So we will connect these 2 points. Okay. If we will connect this, we will have a point of intersection. It is here, the point of intersection. Okay. So labeling our graphs. So this is the first graph. We have 2x plus y equals 16. And then this is our second graph. X plus 2y equals 11. Okay? So there is a particular point of intersection here. So that's how consistent system differs from the other types of system. And graphically, you can now determine this point of intersection. So it depends upon the accuracy or the skill on creating your graphs so that you may visually determine their point of intersection. So visually, the point of intersection of these two equations is 7 and 2. Why? X is 7, then y is 2. So this is now the point of intersection. Okay? So that's how simple we can determine if the system is a consistent system. Okay? So any question? None? Okay, so again, reviewing our example. First, use the ratio test. Consider the ratio test given before in our previous slides. If A and B are not equal, automatically it is a consistent system. If you are tasked to graph, determine the set of points for the first and the second equation. For the first equation and the second equation. Then, after determining the set of points, you may now construct your Cartesian plane and plot the points accordingly based on your solved points. And then, determine their point of intersection. Okay? So, if you have question, you may ask. Okay. So, we have a set of exercises here. Okay? So, we are tasked, or you are tasked to determine whether the following linear equations are consistent, dependent, and inconsistent using the ratio test. So, it is not written here that you need to graph. So, just simply determine the set of equations if they are consistent system, dependent system, and inconsistent system using the ratio test. So this will be your activity to be submitted on our NEO LMS. So again, good day to all our Legionnaires, especially our BSIT students. Have a nice day. God bless and goodbye. This is Mr. Michael M. Flores, greeting you a happy and nice day. Thank you.